Can everyone see this?
Yep.
All right, great. Well, good morning. Happy Friday, everyone. I know there's some folks on here that maybe aren't familiar with our project, so I'm just going to give a brief overview of what it is and a recap of our last two features, pass it to Jamie to talk about the third feature, and then after that, I'll dive into the machine learning model. So our project is a Django-based web app for the detection of diabetic retinopathy. And we're doing this by using a neural network, specifically ResNet 50, to assess severity levels of diabetic retinopathy in retina photos. So for those of you that may not know, diabetic retinopathy is an eye disease caused by diabetes, as the name suggests. But basically, if diabetes is left uncontrolled or unchecked, it can really damage your vision, right? So it can damage the blood vessels in the back of the eye. Diabetic retinopathy is also one of the most leading causes of blindness worldwide. It affects about 40% of patients with diabetes and over 100 million people globally. So it's pretty serious, but it can be prevented though. Like with early intervention, there's a lot you can do. But when you're past that point, you either have complete blindness or surgery, which often doesn't help. And most likely, I mean, it's better than complete blindness, but you'd have to get eye injections every month. And I don't know about you guys, but that does not sound fun. I would hate to get a shot in my eye every single month. So if there was a way to prevent that, I would want that as the patient. So that's kind of what we're trying to do here is just, address this problem and help doctors of early detection of diabetic retinopathy. It's also very important for people who maybe they're in underserved areas, like maybe they don't have the healthcare infrastructure. So that is what the project's about. Let me see if I can move this. I'm trying to get this one thing is like, let me just do this here. Okay, can you see a different screen now? Okay, perfect. So as far as our features, we have already done the image upload where you can securely upload patient images, patient data input. So we have a whole patient dashboard. Each patient has their own little section where they have their name, date of birth, and medical history. And it's not on here, so we probably need to update it, but we also did authentication and authorization, especially conditional access. So if you're a doctor from clinic A, you can only see patients from clinic A. And if you're a doctor from clinic B, you can only see patients from clinic B. So that just helps with secure data and following HIPAA protocol. And our last feature is model-driven analysis. Part of that is the machine learning model, which I'll talk about in a bit. But this also kind of goes hand in hand with our image upload as far as our get and update capabilities and getting it from our cloud database, sending that to the model. So with that, I will pass it on to Jamie to talk a bit more about that feature.
Thank you. I'm gonna go ahead and steal the screen here real quick and move that away so y'all don't get version. All right, everybody able to see my screen? All right. So as Sumi mentioned, we worked very hard on getting this all set up for the diabetic retinopathy. I'm gonna go ahead and kind of just do a walkthrough of our application, just to show you all the different things. So I will go ahead and log in as our user, and then we'll go to the dashboard. And here, this is where you can add patients for whatever you want to add. So I'm gonna add in somebody new. So we're gonna add in Ed, and we got to pick the right Tom Hanks photo here. So let's find a good one. Actually, I think I have a reindeer one. Let's do that one. And then being that it's Christmas, we'll go ahead and set the birthday to then, but we'll set the back way away. Let's just go back to the very first. So we'll add in a new patient. So now you can see that we have a new patient. I'll go ahead and click on them. You can see we have our profile picture. Most of us have already pointed out, yes, this is very much still an MVP. We would love to, our plans are to come back later and be able to make the design a lot better, improve on it, but you can still see the photo of our patient as well as, some basic information that we are storing on them. And then say, for example, they decide to do an eye. Well, we get to choose the eye, like left or right, eye right here. And then we'll get to go ahead and choose a photo. So let's go ahead and pick one that right here that's been scanned. We'll go ahead and add that photo. And then you can go ahead and see it up. That's all the way up from our feature 1 and 2. So now this is where we're starting to get into our feature 3 examples. So our feature 3 is actually being able to take this image and send it to a different server where our model lives, our ResNet model lives, to be analyzed and then get a response back based on that analysis. And that response would be basically the prognosis on it, as well as the confidence scale. So I'll go ahead and push the process button, and you will see it go ahead and get sent off. And then we come on down here to the process images, you can see that the image actually did get processed and we have a prognosis for it. In this case, is moderate. In the beginning, when we first set this up, we actually did have it set up just to ensure the connection, have it where it just returned a random prognosis, but we were able to actually get it connected to the ResNet model to have it where it is actually now being able to detect and analyze the image. So if I was to put the same image in here, for example, and add that photo back in and process it, we will see the same response, because that's it becomes more deterministic because it's the same image. And just to go ahead and show the confidence rating for that, I'm going to kind of let y'all peek behind the curtain. Y'all able to see the my little terminal here? If someone can give me a word, because I actually don't see y'all right now.
We can see you, Jamie.
Cool.
Yeah, we can see.
As you can see in our terminal here, we actually can see that the image and what our response was, along with the prognosis and our confidence. Now, with that being said, as you can see, our confidence rating, it's not that high with our model. And I'm going to let Sumi talk about that a little bit more, but that's something that we have been adjusting and tweaking, and we got it up to this point, and we were really happy that we got it to at least where it was actually given a little bit better confidence, but that's something that can be trained and worked on over time. Same with any other of our features, as feature 1 and feature 2, we are able to do our update. And in this case, we're not able to update the image because we didn't want it to be where you can change the image out, because we didn't want it to be where it's like, oh, now that it's processed, let me change it and make it like mess up the system. But we do have the delete feature for it, because this way, in case that the doctor comes through and decides that they want to remove it, or say, for example, if they delete the actual patient, it recursively goes down and it will delete all the images that are related to that patient. And that's our feature 3, being able to do that. We decided to use Fast API for our secondary server for where our model is served, because that was it holds up to its name. It's fast in being able to implement and to be able to get it where we can then hit our model and get a response back from it for exactly what we needed. With that being said, I'm going to pass it right back to Sumi so she can talk a little bit more about the training that we've done for the model and a little bit more deeper on the analysis of the images.
Thank you, Jamie. Let me share my screen. Can everyone see my screen?
We got you, Sumi.
Perfect. Okay, so yeah, I'm going to dive into the machine learning model process because it was a process. So our training data, we got that from a 2015 Kaggle competition. There is, I believe, 1,100 images, so about 86 gigabytes of data spread across 5 classes, 0 to 4. So 0 is no diabetic retinopathy, 1 is mild to moderate, 3 severe, and 4 proliferative. But the issue is that unlike with most Kaggle data sets, this data was not cleaned at all. This one was particularly noisy in terms of the images and required a lot of pre-processing. It was also very imbalanced. I think we had about 26,000 were all class 0. So for no diabetic retinopathy. So only 9,500 diabetic retinopathy, but that was spread across classes 1 through 4. And not to mention, these images were also taken from different patients using different cameras and at different resolutions. So naturally, that introduced a lot of challenges with different image sizes and qualities. There was a lot of pre-processing that had to be done before training. I will tell you guys, this model was actually trained 3 times. 3rd time's the charm, and that's when we actually got it working. So the very first time, I very much underestimated how much augmentation I had to do. Because I just, I flipped some images around, I did horizontal flip, yada, yada. I was like, yeah, that'll be fine. It was not. So the model was returning only class 0, only no diabetic retinopathy. Like it could not detect the other classes at all. So I said, okay, well, I'm going to oversample the less represented classes to add more of them. But the issue is that my script was wrong in that it didn't actually augment those classes. It only duplicated the images. So then that caused issues of, 10/left copy or 10/left 1, 2, because the image paths weren't matching up with the CSV labels anymore. So I was like, okay, I got to try to figure this out. So the solution that worked was that first we cropped the images to a resolution of about 1800, resized them to 224 pixels. After that, I had to remove about 400 or 500 black, just completely black images from the data set. And then I think what helped the most is rotating and mirroring the images. So we mirrored the images from classes 1 to 4, rotated them 90, ma'am, you have to sit down. Sorry. My cat is wanting attention. So we had to mirror them and rotate them to like 90, 120, 180, 270, and then converted them into NumPy arrays. And then it worked. Then it was actually augmenting them. And that was just done to address the severe class imbalance. And I can show you here. Are you guys seeing a different screen? Can you say something? Do you guys see a Google Drive screen now?
Yes, we do.
Yeah.
Okay, perfect. So this is before augmentation, and this was done with Matplotlib. So as you can see, extremely imbalanced, all for class 0. I forgot to put the classes here. And after augmentation, it was much more balanced. This 55,000 is spread over classes 1 through 4, but it gave the model more to go by. Like it wasn't just seeing what no diabetic retinopathy was. So that definitely helped stabilize the model's training process. And also something here is just pretty cool to see some of the pre-processing. So here you can just see the model, we have it 90 degrees, 120, 180, 270 and mirrored. And that helped a lot as well. So as far as the training process goes, the data is split into 80-20. So 80% trains the data and helps train the model. The 20% is used to validate. So that's stuff for like the fine tuning that we were talking about, the different parameters. And then the ResNet 50 is the convolutional neural network we're using. I chose that one because it's more familiar with image processing. The only downside, though, is that it's kind of canned, it's kind of limited. So I feel like in the future, maybe I would try a different neural network, but this was good for what we had. And then a quick breakdown, use TensorFlow and Keras for the training of the model. And then for like the pre-processing, that was NumPy, Pandas, other libraries, and then Matplotlib for the visualization. And also to speed up the process, we used CUDA, which I just found out about that. So I can use the GPU instead of the CPU, because the first 2 times it took about 10 to 11 hours to train, but that was using CPU. So when I switched to GPU, it only took like 3 or 4 hours. So that was a major difference. And then, like Jamie was kind of showing, we have our patients here. And the retina photos, you can see what's been processed and what is not. And if we process this, it should return a result. Yeah. So I will say this model is much better than it was at the beginning, but it does tend to favor moderate and mild classes. So I still don't think it's necessarily detecting the severe classes as much as I would like. But that's something that we can do in the future. And it's still much better than it's saying no diabetic retinopathy at all. And I think Jamie kind of went over this, but the images are uploaded to Cloud Neri, and then the Django server gets it through our URL, images analyzed, and then with the fast API endpoint, it's sent to the ResNet model, and then it displays the result back on the dashboard. And that's all I have for my part. I think well, let me look at the questions.
I was about to say, I think now we're in our phase now.
The questions, yeah. Are you happy with the tech stack you chose? Why or why not? I'm happy with it. I felt like Fast API, like you said, was fast. It was great. Django had a lot of modules and like a lot of like pre-canned stuff that helped a lot. And TensorFlow and Keras, I don't really know what I would use other than that for the model. I'm sure there's something, but nothing I know of at the moment. What do you think, Jamie?
Yeah, I think for the tech stack, I'm very happy with what we chose. I remember in the beginning that we were kind of thinking that everything was going to be housed in one server, like we were going to have even the model integrated in there instead of having it separate that we would actually hit. Come back, looking back, we probably could have done a completely different tech stack if we wanted to for our main web application, but I'm still happy that we used Django. There were some like a lot of learning curves for it because it does have a lot of things that come kind of built into the system. So we kind of had to learn how to work with those because neither of us have touched Django before. But that's why, and the reasons why I'm glad we did it, because that way it was a completely new learning experience. It's not like I'm just doing something I already know kind of thing. So that was a lot of fun. And then yeah, and when it came to actually setting up, once we got to the point where we knew like to actually for the model, using that fast API was fantastic because it was one of those like, okay, we already know what we need to do. We just need to have a simple endpoint. We don't need to use Django again to do all this other stuff because we don't need it. So let's just use something quick and basic, and it held up to it. So kudos to our mentors and our the support staff to be able that made that recommendation, because we were looking at a couple of options, but that was the one that we decided to go with for it. Um, as far as our next question, what's the most surprising thing you've learned as part of this project? I personally feel that it would be one, the technologies, because I've not really touched Python coming into this at all. As a few of the other apprentices have mentioned, we've been mainly focused on that one at the Booz Island side, but also for just learning new technologies really helped kind of like get that more breadth experience to understand how different languages kind of are similar but also somewhat different. I also feel as part of this, I wasn't expecting in the beginning, but I'm really happy is that I definitely feel I've improved on my communication skills and like being able to be collaborative and working with partner. So with Sumi, we had I feel it's been a great partnership and that we've done a fantastic job together. And it's been a really nice thing to learn. It wasn't something that I was expecting to go in. I was like, oh, here's just another project. I'm just going to learn more code. But it wasn't just that. It was also the collaboration aspect to it too that I thought was really, I feel like that one kind of was like, I wasn't expecting, but I'm really happy that happened. What about you, Sumi?
Echoing what you said, yeah, pretty much the same. I was surprised how much I liked the collaborative aspect. I did have to learn kind of how to work with someone because I've never worked on a team before or did like a pair project, but it was nice not having to do everything by myself and being able to rely on someone. And I just think we had great project management skills and dividing up the task. And as far as anything else surprising, I mean, honestly, everything, how much the Git history can affect things. Chris and
Yeah,
Alex know they helped us with that.
yeah,
Um, yeah, because we had some issues where even though we had the model and data and the Git ignore, it was still in history, so naturally couldn't push that up. And yeah, I mean, I guess I just learned a lot, but the Git history part was the data, the fact that most data is not going to be cleaned or balanced because it's going to reflect real life. So I think I somewhat knew that, but I didn't realize that as much until I started actually working with it. So that was a surprise. What's the wave of magic one? What's one thing you would change about your approach? I don't know. So I have an answer, but I think that it actually ended up being a good thing. I was going to say that originally I was using Coursera to do this and learn how to build a ResNet model. And it was only about 3,500 images. And I was going to say that I wish I would have exported all of that instead of trying to do it all in the Coursera platform, because then the course was deprecated and I had no access to it anymore. On the same hand, though, I learned a lot by doing a lot of this myself. It was very stressful, I'm not going to lie, but I feel like I learned way more by trial and error and testing this out, especially with a more diverse data set than I would have if I just stayed on the Coursera platform. So it was very frustrating, but I don't know now if I would change that. I guess my other thing would be to just evaluate the data set a bit more and just kind of see beforehand, if things are how processed they are. Because I know not everything's going to be cleaned, but some stuff on Kaggle is a bit more clean than other data sets. So yeah. What about you, Jamie?
yeah. I've been having a hard time trying to think about this one, just because I actually feel we did like really well for our approach. I mean, hindsight's 2020, like I kind of mentioned earlier, like we could have done our main web application in a different technologies if we wanted to. And like it sure it would have made things a lot easier, but I'm glad we didn't because it was a lot more that we got to learn and be able to get that experience for. Yeah, really, I don't really know much about what else that we would change for it because I felt like that we kind of like we had our we laid out our battle plan in the beginning. We kind of stuck to it. We really did. I mean, admittedly, like our feature two kind of bled over into our this sprint. Like in the beginning of this, we were trying to wrap up a few things that we weren't able to finish. But just like at the end of this, there's lots of things that we want to go in and tweak and it done. The only I'm gonna steal some on one of the other princes. I forget who it was. I don't know if it was Morgan or Ian who was saying it, but like in the beginning, I was really wanting to make everything pretty, like always pretty. It's like, oh, it's got to be perfect pretty. And like, I was really hampered on that. And like during our feature one, and then I learned really quickly that doesn't necessarily matter. We don't necessarily need it to be pixel perfect. Let's just get it where it's actually displaying. Then we can come back later and make it pretty for it because that's it. That wasn't necessarily like the main part of it. It's like let's get it actually functional before we can actually make it look nice. So I guess that would be my answer. Is about for me personally, not be get hung up on the design. I come from a graphic design field, so not get hung up on the design and focus on the feature itself. Exactly, make it work, then make it cute. So, I guess with that, if you're cool with it, Sumi, we can open up the floor to questions.